Hello students, welcome to chemistry class. Today we are going to discuss about the chemical properties of amines. In that first reaction, that is acylation of amines. So the primary amines on reaction with the acid chlorides. Generally acid chlorides are RCOCl or C double bond O Cl or anhydrides. So anhydrides means R C double bond O and C double bond O and it is R group. So the primary amines reacts with the acid chlorides and acid anhydrides in the presence of a base. So that base is stronger than amine. That is, that base are generally stronger than the reactant molecule. So like pyridine, so which removes HCl so formed and shift the equilibrium to the right hand side and it gives the nitrogen substituted amides. For example, let us take ethanamine, that is ethanamine. So the formula for ethanamine is eth, that is it contains C2H5 group eth and amine is NH2, that is two hydrogens attached to the nitrogen. So the nitrogen contains one lone pair of electron, so it reacts with the acid chlorides, that is CH3 and it is C double bond O and it is Cl. So it is to be called as acetyl chloride. So the lone pair of electrons gets shifted to the or transferred to the positively charged carbonyl carbon, and the double bonded electrons are shifted to the oxygen. So it gives the intermediate step and the reaction takes place in the presence of base. So that base are generally stronger than the amines, and the obtained intermediate is, that is C2H5, so and it is nitrogen. So that nitrogen contains two hydrogen atoms, right, and the lone pair of electrons are transferred to the carbonyl carbon. So this CO group is to be called as carbonyl carbon and it is C. So it is O minus. So minus is because of the presence of extra electrons, because the double bonded electrons are transferred to the oxygen atom. That double bonded electrons are to be represented as minus charge and it is CH3 and 1 Cl, and this nitrogen gets positive charge because the lone pair of electrons are to be transferred to the carbonyl carbon. So due to the loss of electrons on the nitrogen atom, it gets positive charge. So finally, so there is an elimination of HCl, that is nitrogen charge is to be balanced by the release of one hydrogen, and the negative charge on the oxygen atom shifted to the carbon and the halogen is eliminated. So it gives the product, that is C2H5 and it is N. So it contains only one hydrogen and lone pair of electrons and single bond, and it is C double bond O and it is CH3. So this molecule generally to be called as N-ethyl ethanamide, right. So amide is to be because of the presence of NHCO, that is the obtained compounds are generally to be called as N, that is nitrogen. To the nitrogen ethyl group is to be attached, so N-ethyl, and it is to be, and because of the presence of two carbon atoms it is to be represented as eth and An, and the functional group is amide. So N-ethyl ethanamide. And let us see one more example, that is N-ethyl ethanamine. So N-ethyl ethanamine, that is N ethyl ethanamine that is two ethyl groups attached to the nitrogen, and there is one hydrogen. So this nitrogen contains one lone pair of electrons. So it reacts with the CH3 CO Cl. So it is acetyl chloride. So there is an elimination of hydrogen and Cl. So in the final product there is an elimination of hydrogen and halogen, right? So directly there is so here I am going to eliminate the hydrogen from the amine and halogen from the acid chlorides, and the reaction takes place in the presence of base. So it gives the product, that is two molecules are to be combined. So it gives C2H5 and it is N. So it is C2H5 and lone pair of electrons, and this nitrogen attached to the carbonyl carbon, right? So it is C double bond O and it is CH3. So the obtained molecule is to be called as N, that is two ethyl groups attached to the nitrogen. So it is N, diethyl, and the root word is 1, 2. So it is earth, and the nature of the bonds AN, E is replaced by amide. So it is N, diethyl ethanamide. So this reaction generally to be called as acylation reaction. So during the acylation reaction, the primary amines reacts with the acid chlorides or acid anhydrides. So in the presence of a base stronger than the amine, that is the base is generally pyridine. So that pyridine removes the HCl so formed in the chemical reaction. It shifts the equilibrium to the right hand side. That is, it increases the concentration of the products, and the obtained product is to be called as N substituted amides. And let us see how this primary amines reacts with the acid anhydrides. That is C6H5 and it is NH2. So the nitrogen contains one lone pair of electrons. So this molecule is to be called as benzenamine. So this benzenamine reacts with the acetic anhydride, that is CH3. So it is C double bond O and C double bond O, and it is CH3. So this molecule is to be called as acetic anhydride. So during the chemical reaction, that is hydrogen is to be eliminated along with the CH3COO group. So it gives the product, that is chemical reaction takes place in the presence of base, that is pyridine. So it gives the product, that is C6H5 and it is NH and C double bond O CH3, and the byproduct is, that is CH3 and it is COOH. So it is acetic acid. So the obtained product is to be called as acetanilide. So this compound is to be called as acetanilide. Or this molecule is also to be called as N, that is phenyl group attached to the nitrogen. So it is N phenyl, and two carbon atoms are to be represented as earth and An, E is replaced by amide. So N phenylethanamide. So this is acylation reaction. Let us see the next reaction, that is to be called as carbylamine reaction, or it is also to be called as isocyanide test. Very important reaction for the competitive as well as for the theory exams. So the primary amines, that is aliphatic as well as aromatic primary amines, on heating with the chloroform and ethanolic potassium hydroxide, that is alcoholic potassium hydroxide, it forms isocyanates, or it is also to be called as carbylamines. Generally this carbylamines has foul smell, that is the obtained compounds has foul smelling substance, and this carbylamine reaction generally used for the test for primary amines. So the primary amines are to be identified by using the carbylamine test. Let us see how these isocyanates are prepared. So the general reaction are NH2, that is amines, primary amines. So this amines reacts with the chloroform, that is CHCl3, in the presence of alcoholic potassium hydroxide, that is alcoholic potassium hydroxide. So the reaction takes place above room temperature, that is on heating. So it gives the product, that is RNC, that is N triple bond C. So these compounds are generally to be called as isocyanides. Plus the hydrogen atoms are to be combined with the hydroxyl groups, so it gives H2O molecules, plus the potassium combines with the Cl, so it gives potassium chloride, and the reaction is to be balanced by writing the 3 moles of potassium hydroxide and it gives 3 moles of Cl, right? Here there is an 3Cl, so in order to balance the chlorine we are writing here 3 moles, and in order to balance the potassium, so we have to write 3 moles of potassium hydroxide. So this reaction is to be called as carbylamine reaction. For example, let us take CH3NH2. CH3NH2. So it is to be called as methylamine. So this methylamine reacts with the chloroform CHCl3 in the presence of potassium hydroxide. So it is alcoholic potassium hydroxide on heating. So it gives, that is hydrogens eliminated along with the hydroxyl groups as water molecules, and nitrogen combines with the carbon, so it gives the product, that is CH3NC. so methyl, and NC is to be called as isocyanide, plus the byproducts hydrogens combines with the hydroxyl groups, so it gives H2O, and potassium combines with the chlorine, it gives 3 moles of Kc, and we have to balance the hydrogen atoms, right? So in the reactant molecule it contains 2, 3, 4, 5, 6 hydrogens, but in the product side it has only 2. So in order to balance the hydrogens we have to write 3 moles of water molecules. Like that, in this reaction also 3 moles of water molecules. So in the carbylamine reaction, or it is also to be called as isocyanate test, so the primary amines are to be identified. So this primary amines reacts with the chloroform in the presence of alcoholic potassium hydroxide, so it gives isocyanates. So this obtained isocyanates has foul smell. So that foul smell is due to the formation of isocyanide or carbyl amines. And let us take one more example, that is CH3 CH2 NH2. So it is to be called as ethyl amine. Ethyl amine. So this ethyl amine reacts with the chloroform CHCl3 and alcoholic solution of potassium hydroxide on heating. So it gives the product, that is hydrogens and hydroxyl groups are eliminated, potassium and Cl eliminated as KCl, and the remaining product is, that is CH3 CH2 and it is NC. So it is to be called as ethyl isocyanide. Ethyl isocyanide, or also to be called as ethyl carbyl amine. Carbyl amine. And the byproducts, that is potassium combines with the Cl, so it gives KCl, and the hydroxyl groups combines with the hydrogen, so it gives H2O molecules. And the number of moles of KCl is 3 and water molecules 3 and potassium hydroxide is also 3. So very simple reaction. When the primary amines reacts with the chloroform in the presence of alcoholic potassium hydroxide, on heating it gives isocyanates. Next, let us see the reaction with the nitrous acid. That is, nitrous acid is to be obtained by the mixture of sodium nitrite and concentrated hydrochloric acid. So this primary amines, that is primary aliphatic amines. So primary aliphatic amines reacts with the nitrous acid, so it forms aliphatic diazonium salts, which being unstable and decomposes to give alcohols and nitrogen gas. Let us see how this primary aliphatic amines produces alcohols. So the general formula for this reaction, that is RNH2. So it reacts with the nitrous acid. So this nitrous acid is to be released by the reaction of sodium nitrite in the presence of concentrated hydrochloric acid. So it gives the product, that is diazonium salt, that is RN2, and it is plus and halogen Cl minus. So this compound is to be called as diazonium salts. Diazonium salts. Already this reaction is to be discussed in the alcohols chapter, that is preparation of alcohols. Again, this diazonium salts undergoes decomposition, that is in the presence of water, so it gives R and it is OH. So hydrogen combines with the Cl, so it gives HCl plus nitrogen gas is eliminated, right? So this compound is to be called as alcohols, that is methylamine CH3NH2. So it reacts with the nitrous acid. So nitrous acid is NaNO2 in the presence of HCl. So it gives the intermediate product, that is CH3 N2 plus and halogen minus Cl minus. On decomposition, so it gives the product, or on hydrolysis it gives the product, that is CH3 OH plus HCl plus N2 gas. Next, let us see in the case of aromatic amines. Same reaction, instead of alkyl group, take aromatic ring, that is C6H5NH2. So this molecule is to be called as aniline. So when aniline reacts with the nitrating mixture, that is NaNO2 plus hydrochloric acid, concentrated hydrochloric acid. So this reaction takes place at temperatures 273 to 278 Kelvin. So there is an formation of an intermediate, that is C6H5N2 plus, and it is Cl minus. So this compound is to be called as benzene diazonium chloride. Diazonium chloride. Next, on hydrolysis, so there is an elimination of product, that is OH and hydrogen. So it gives the product C6H5 and it is OH plus N2 gas plus HCl. So the obtained product to be called as phenol, right? So phenol is to be prepared from the aniline by using nitrating mixture. And next reaction, that is a reaction with the Hinsberg reagent, or it is also called as aryl sulfonyl chloride, that is aryl, so benzene ring, and sulfonyl, that is S double bond O, and it is chloride. So this reagent is to be called as Hinsberg reagent. Let us see how this primary amines reacts with the Hinsberg reagent, that is C6H5 and it is NH2. So this primary amines reacts with the benzene sulfonyl chlorides, that is S double bond O, and it is Cl. So there is an elimination of HCl. Simple reaction. So it gives the product C6H5NH and it is attached to the S double bond O, and it is C6H5. So this molecule is to be called as N-ethyl benzene sulfonamide, that is ethyl groups attached to the nitrogen. So it is N-ethyl and benzene also attached to the sulfonic group, that is ethyl benzene, and sulfonyl S double bond O is to be represented as sulfonyl N, and YL is replaced by the amide. So it is sulfonamide, N-ethyl benzene sulfonamide. And next let us see in the case of secondary amines. Secondary amines means the two hydrogen atoms in the ammonia replaced by the alkyl or aryl groups. So benzene sulfonyl chloride, S double bond O Cl. So it reacts with the secondary amines, that is two ethyl groups attached to the nitrogen, C2H5, and it is hydrogen. So there is an elimination of HCl. So it gives the product, that is S double bond O, and it is double bond O. So it is N, so C2H5 and it is C2H5. So this molecule is to be called as N, diethyl, that is two ethyl groups attached to the nitrogen, N, diethyl, and C6H5 is benzene, and sulfo, and YL is replaced by amide, sulfonamide. So N, dimethyl benzene sulfonamide.